Hello everyone, my name is Ezgi Çavaş. My team members are Hasan Karada and Hasan Ziyade. Today I will present our exploratory data analysis for our dataset. This is a basic roadmap. Step 1 is exploring the correlations between our features. Step 2 is exploring the samples using visualization. Step 3 is handling the missing values. Step 4 is handling the outliers. Step 5 is handling the values of numerical and categorical features. Continuous, not numerical, sorry. Let me correct myself. Step 1. At first, we looked at the correlations, using the correlations widgets in Orange.
Can I interrupt you for a second?
Yes.
So as I suggested in the previous presentation, it's a really good habit to begin with the data set, the goal of the data set, or the goal of your project, what you would like to do with that project, with that data set clearly, and give it the target values or target class, target, it is that regression problem. So we don't remember your data set. So what's your data set? What's your problem? It's so you just jump into the EDA. Do you understand me?
Yes, since we did it.
Could you please, again, introduce the data set, the project title, and the target values, binary classification? What are you dealing with? Could you please start with that?
Let me show it. Since we did it in the initial dataset presentation, I didn't want to repeat myself. That's why I didn't include these slides. But let me introduce our dataset again. It's a linear regression problem about apartment rental offers in Germany. Why we chose this? Because it's not easy for humans to predict the rent price of a house. And also we want people new to a country to have an initial idea about housing prices. That we want to prevent them from being scammed. And we want them to choose an area to live in. We want to help with that. It will be supervised. It will be estimating the price of a house, rental price. So it will be regression. This is the summary of our data set. We first looked at the correlations using the correlations widget. At first with Pearson correlation, which explores the linear correlation. It seems that these features have very low correlation. However, when we decided to change the correlation to Spearman, which explores nonlinear correlations, we saw that actually some of the features indeed do have low correlation, but the correlation features changed. That's why, for example, number of floors seemed to have zero correlation, but we couldn't remove that feature because it has a non-linear correlation. Actually, it has a correlation. So no linear correlation doesn't equal to having no correlation. Step 2, we have some basic visualizations.
Ezgi,
yes?
Could you please tell us which orange widget you use for that reason?
Yes, of course.
So in your presentation, if you have the screenshot from the orange, it would be very beneficial for others to follow and to replicate your work.
I have many things.
If it is in handy, you can show us. Otherwise, you just mention and move on. It's up to you. You can show us or you can just...
Here, I found it. Can you see my screen?
Not now.
Okay, let me...
seeing the presentation.
Okay, let me share the... Hocam nasıl değiştireceğim ekranı?
Durdur share etmeyi. Yeni share diye seç.
Okay. Hocam bütün şeyimi paylaşabiliyor muyum direkt screen'i? Hani
evet,
geçiş olmasın diye.
Evet, orada oluyor.
Okay, can you see it now?
Yes.
I used this widget, correlations, and here we can change we can select either Pearson or Spearman.
Okay, thank you for sharing this so everybody would understand how you use it, right? Okay.
Yes, yes, okay. I wanted to see the change of values between our target feature, which is total rent. The correlation, I mean, not correlation, let me say relationship between base rent and total rent is almost linear, which is, I think, acceptable, like it isn't abnormal. Because since base rent increases, total rent will naturally increase. But we can also see that we have some outliers here, which we need to remove because it doesn't seem very realistic.
Ezgi.
Yes.
As a common thing, okay, so when you share some figure, you need to provide us the X and Y axis and the legend. Now we don't know what is blue, what is yellow.
Oh yes, I'm sorry, I forgot.
X-axis, what is the Y-axis? So it's not a good thing to screenshot like that. Do you understand? Okay.
I forgot to mention base rent is our Y-axis here.
Yes, but for you, instead of getting this screenshot like that, please capture the screenshot, including the legend, X-axis and Y-axis from the orange. I think you got it from orange, right?
Yes, yes.
Because you are gonna put all these presentations details into your final report. So I need to read and understand. If somebody try to look at this figure, nobody would understand what it is.
Okay. I mean, we are going to change screenshots anyway for the report. I just didn't want to,
in your presentations, in your future presentations, please note this, okay, for everyone.
Yes, of course.
Don't take this center zone, okay? Just get the X, Y, and legend.
Okay.
And now, please mention about the X-axis, Y-axis, and the legend. Okay.
So here, our Y-axis is total rent, while our X-axis is living space. This shows that living space doesn't change dramatically, even though total rent is always going higher. Living space is always limited between some values. But still, there are also outliers here, which need to be eliminated. Our Y-axis here is year constructed. Our X-axis is total rent. Again, it was something we expected because these are newer constructed buildings. The year is newer. Although there was one example that said the year constructed was 290, which was impossible. So that sample would need to be removed. And we can see that buildings that are really old have lower rent prices compared to newer buildings. And then we looked at the condition. Our total rent is Y-axis, condition is X-axis. Means condition and first time use after refurbishment or fully renovated have higher rent prices as expected, and the condition that is need of renovation has lower rent prices, again as expected realistically. And then since the correlation was one of the highest in service charge, we want to make a scatter plot of this as well. Service charge is our Y-axis, total rent is our X-axis. Again, the same as living space, the service charge seems to be limited between numbers. It doesn't change very much, doesn't change dramatically, but still there are some outliers that needs to be taken care of. And then we wanted to see total rent distributed by location. Location by that we mean states of Germany, just like states of United States. And we can see that Thüringen has the least number of samples. So maybe we can, to make our models better, maybe we can select, I don't know, six most states that have many samples, something like that. But we are not certain of that yet. Step 3 is missing values. We have decided to delete columns, features that have more than 30% missing values. And we have also checked their correlation to make sure that the correlation wasn't high, both linear and nonlinear, so that it wouldn't make a great difference. Total of 11 columns to delete. I didn't want to specifically list all the columns because I thought the time wouldn't be enough. I'm sorry for it.
But Ezgi, do you think that it's a good idea to remove 11 features because they have some missing values? These are the missing values, 83% missing values?
Yes, but the feature that has 83% is something like kilovolt hash. I mean, like.
Okay, they are not, looks like related with the target.
And, and we also looked at the correlations and we confirmed that they weren't very important.
Okay, thank you.
Okay. So we will also delete features that do not have useful information. For example, picture count, house number, and there was also a feature named Scout ID. Like if you wanted to rent a house, you wouldn't look at the Scout ID to price it realistically. And then we also have some missing values left. We wanted to, for example, there are some missing values in condition. The missing values can be labeled as others, we believe. And continuous features that still have remaining missing values can be filled with the mean of the value of that feature. Also, we discovered that there are some samples that don't contain the target value. I'm sorry for not taking a screenshot. Since we are doing supervised learning and we need to know the targets, we can just delete those samples. They are useless to us, we think.
Ezgi, when you report these kind of things, you need to use as an engineer the numbers. How many?
Okay, I'm sorry, I didn't include.
What is the percentage? How many? So as an engineer, please do not narratively talk, but provide some numerical information, all right?
Yes, but from what we can see, it's at most 1%, the samples that do not contain the target value.
Okay, if it is 1%, write 1%. It's 1.3%, write 1.3%.
I'm not sure of the exact number, yes. Yes.
Do you understand my point?
Yes.
Okay.
Step 4 is handling outliers. We have also seen outliers in the scatter plot, but we believe that box plots would show the outliers better. This one shows us the base rent. This is a box plot of the base rent, and we can see how it gets to 1 million billion. So we need to also drop these samples because they are simply unrealistic. For example, if you have 5,000 rooms or like 10 to the power of 7 point rents, you wouldn't, as a normal person, go looking for houses like this.
Actually, I cannot call them outliers, most probably. Most probably their rent prices are entered mistakenly. They are incorrect, I believe, right? Maybe there are some typos.
Yes, maybe. probably also
they are not the outliers, because outlier concept, you know, is a little bit different than the mistake.
Yes, probably yes, I know the difference, but I just believe that, you know, maybe some houses are like crazy, you know, I don't know.
Okay.
Okay, but we know the difference. Step 5, handling values. Actually, we are not sure if we use normalization. Like we need to test, I think we need to test both of them. If we have to normalize some features. For example, living space. We wanted to actually ask you about it, if it would improve our predictions or if we should just leave it as it is. Also, for some features, there are the exact values of that features, and then there is the range. So the dataset seems to have done the binning for us, actually, for some features. So we considered removing the normal features or removing the binned features because the two of them are redundant.
Ezgi, again, for that kind of information, either you can show us some samples as a screenshot from Orange, or you need to provide some numerical information. How many of these features has the range? How many of them blah blah small? You understand me? So
yes, I'm sorry
you overlook the data set and we don't have the insight.
Yes, I'm sorry for not including screenshots. And also, to keep the values consistent, we need to check whether, for example, meter square, whether they are all in meter square or there are some mistakes, and in that case, correct it. Do you have any questions?
Yes. Are you one-man show? So where are the other team members?
No. Like since our initial data set, I was the presenter, so that's why I'm the.
But I sent you email, and it's written in the documentation that everyone must take part in the presentation and answer my questions. Otherwise, I thought that, I consider that, I assume that the others wouldn't contribute to the project.
I understand, Jamie. I think we didn't focus on that.
For the future presentations, please pay attention to that.
Okay.
Otherwise, other team members will lose grades.
Sure, Hocam.
Okay.
Okay.